Hello friends, welcome back to my channel. Well, I am going to start a new series on Kubernetes in which I will cover beginner to advanced level, also the production ready scenarios. Let's get started. In today's session, I will cover what is Kubernetes, its official definition, and the traditional way of deploying an application and the deployment challenges we used to face, and how containers help us to fix those challenges or fix those issues, and what problem does Kubernetes solve. Let's talk about the official definition of Kubernetes. Well, Kubernetes is an open source container orchestration framework. So it manages containers, be it in Docker or from some other technologies like Containerd, CRI-O, Podman. It was originally developed by Google. So Kubernetes helps us to manage the applications made up of hundreds or maybe thousands of containers. It helps us to manage them in different environment like physical machines or virtual environment or clouds or even the hybrid environment as well. Now let's talk about the challenges which we used to face using the traditional way of deployment approach. Suppose we have two Spring Boot applications. Those rely on similar dependencies but use different versions. Uh, for example, Spring Boot application 1 is using MySQL, Jacoco, Java with these set of these versions, and the Spring Boot application 2 is using same dependencies but different versions. It's going to be a challenge if you are trying to run two applications on same machines but with different versions of binaries and libraries. Let's take another example. If you want to build and deploy Django based application or different Django based Python applications with certain set of binaries and libraries, although Django provides solution for this as it provides virtual environment concept that helps us to isolate the packages into different virtual environments. For example, virtual environment 1 can contain the packages for application Django application 1, and virtual environment 2 can contain the packages for Django application 2. This is okay, but it won't help if there is certain packages or the application is relying on some packages on the operating system itself. So to summarize this, we can say it is difficult to manage different versions or dependencies for different application on same operating system. Okay, now let's talk about the another challenge which we used to face using the traditional way of deployment approach. Suppose we need to deploy an application in multiple environments, like in dev environment followed by test environment and production environment. In dev environment, we have used certain version or set of dependencies. What happens when that app gets deployed in test environment and in production environment as well? We will need to maintain the same set of dependencies in all the environments. We will have to make sure that we have set up the environment the same way with the exact same dependencies. If you change something in dev environment, you will have to make sure it gets updated in production environment and also in test environment as well. Otherwise, app won't work the same way it was working in the development environment. So we will get the issue like working in my local problem will arise. Now, what can be the solution for such challenges which we used to face in the traditional way of deployment approach? Let me explain it this way. What if we build an image that consists of application itself and all of its dependencies at both the application level and the system level, and package it and use this exact same image in all the environments, be it development environment, testing, or followed by production environment. That way, anytime you make a change in future, the image is rebuilt and the same image is used in all of the environments, no difference in different environments. So how can we achieve this? So this is possible using containers. We all know what container is. Well, container is a running instance of an application created from an image. So Docker is one of the most popular containerization tool. So we can say containers help us to create an isolated environment for our system. We can run different applications with different versions of dependencies not impacting each other. Containers allow us to build the images based on the operating system as well. So we can use CentOS, Ubuntu, Red Hat, or any other operating system as a base image for our containers. So how the container gets created? We write a Docker file. From this out of this Docker file, we create the Docker image, and from this Docker image we create the Docker container, which is a running instance of our application. Also, Multiple applications can be deployed on the top of same server using different containers, because containers create isolated environments for each of the applications. So it is possible to deploy multiple applications on the same server. Well, there are certain limitations of container. Containers are ephemeral in nature, means a container can be started, stopped, or destroyed very quickly. We can say containers are short-lived. Also, like containerization tools like Docker doesn't provide support for auto healing. Means if a container dies, it cannot come up automatically. DevOps has to bring it up manually. The same way, no auto scaling support. Containers count or number of instances should be increased or decreased as per the traffic, but Docker doesn't support this. The next one is no enterprise support. Means Docker is a very simple platform. It doesn't provide any enterprise level support like load balancing, firewall, auto scaling, auto healing, API gateways, and all. So solution of all these problem is Kubernetes. We will discuss it later. But now let's have a quick demo on Django based application. I will show you how to install and run the application manually, then by using Docker. Well, I'm having source code available in my local. First of all, I will show you how to install and run the application manually, then by using Docker also. To run the application manually, we will first of all need to install the required packages mentioned in the requirements.txt using pip install command. Once it is done, we will run the server directly. Okay, as I have already mentioned, Python is interpreted, not compiled, so Django code runs directly with the Python interpreter. No build compile steps is needed. So if I run this command pip install -r requirements.txt, it will read this requirements.txt, all the packages, and it will install all the packages one by one in my local. So I have already run this command, so all these packages are already installed in my local. It will show me all the requirements already satisfied. Okay, once it is done, I will simply run the server using py manage.py run server. The default port for Django application is 8000, so I will let my application run on 8000 port itself. So when I access this URL, so my application is accessible. Let me quit this application because I will demonstrate the same thing using Docker. So now my application is not accessible anymore. Okay, now write a Docker file. Well, what is Docker file? Docker file is a combination of instructions. So first instruction which we use in Docker file is from instruction, in which we use some base image. As it is a Django based application and Python is required, so I am using Python as a base image for this Docker file. So from the Docker official images, I am using Python 3.11 Alpine. Alpine images are lightweight, so using that image. Once it is done, next instruction I will use workdir. Workdir sets the working directory. It can be considered as CD in Linux. So once this container spins up, it will CD to /app location. Then I will use copy instruction. It is similar to copy command in Linux. It will copy the requirements.txt from my local inside the container. Then the same way which we have done manually, we run this pip install -r requirements.txt. The same command I will run using the run instruction. Run, then pip install -r requirements.txt. Here I will use -- no cache dir. No cache dir prevents pip from storing these files in cache pip dir, so that image size will be reduced by not caching temporary files. Then I will use the copy instruction to copy the application code into inside the container. So once it is done, finally I will run the command to start the server. So we will use cmd. So whenever the container spins up, so it will run this command to start my application. Python manage.py run server. Here I will use default port 8000 only. Okay, next step is I will start I will create a Docker image from this Docker file. For that we'll use first of all, this Docker file is available in my local. So I will just run Docker and Docker is already running in my local. If I show you Docker hyphen version, so Docker 2801 I'm using, and it is already running. So using Docker build command, we will create an image. So Docker build hyphen T is for tagging. I am giving it name as SCH solution, and version I am giving 1.0.0, and Docker file is available in my local and the current location, so dot I will use. Okay, so Docker image being created. If I do Docker image ls or Docker images, so it will show me SEH solution with tag 100 11 seconds ago created. Next step is to spin up a container out of this Docker image. So by running Docker run command, we run one instance of our application. So Docker run hyphen dt is for detached terminal, and the name of my container is SCH solution, and I will do port by I will use hyphen p to assign the port. Host port is 8000. So host port of my machine, the 8000 port of my host machine will be mapped to 8000 port of container in which my application is running. Then I will provide the image name or image ID, or I can provide, so I will provide image ID here. When I hit enter, a container will come up. So if I do Docker ps, so I'm having a container which is created 5 seconds ago and started also, and which is mapping 8000 port of my host machine to 8000 port of container. So if I run the application using a localhost colon the port is 8000, my application will be available. So that's all for now. In next video I will explain Kubernetes architecture. Thank you.